Alright, tonight we're going to look at the layers of the Earth. Last night we looked at how scientists learn about these layers, and tonight we're going to explore what these layers are. So let's go ahead and get started. Now, if we were to cut the Earth open like an apple, like you see in this picture here, we would see that the Earth is not uniform all the way down, just like an apple isn't, right? You've got a skin, you've got the apple that you part that you would eat, and then you've got a core. Same way the Earth has a skin, we call it the crust, an inner part, and then we've got a core to our planet as well. And so let's look at each of these layers. First though, a quick note on temperature and pressure inside the Earth. So for both of these, as you go towards the core, the pressure is going to increase, right? And if we think about this, this makes sense. You've got more and more rock above you pushing down, and so there's going to be lots more pressure. Temperature, the deeper you go into the Earth, the more the temperature increases, right? And it's actually because of this pressure. All that force pushing down causes the molecules to get squished tight together, and when they try to move, they create a lot of friction. So the temperature, every about 40 meters that you go down into the Earth, the temperature rises about 1 degree Celsius. So by the time you get to the core, it is quite hot. And we'll talk about that when we get there. We'll start our journey on the surface, looking at the Earth's crust. All right, the Earth's crust is the thinnest layer on Earth. It's only 5 to 100 kilometers thick. All right? It is a layer of solid rock that includes dry land and ocean floor. Right? So not the oceans itself, not the water, but the rock on the bottom of the oceans. We've got two types of crust that you need to know about. We've got oceanic crust, which is made up mostly of a rock called basalt. It's under the ocean, obviously. And it's much thinner than continental crust. It's only 5 to 7 kilometers thick. All right, so from the top of that to the bottom of the oceanic crust is only about 5 to 7 kilometers. That's about 3 miles. All right, so it's more dense than continental crust because it's got more iron in it. That's what makes it dark in color. Continental crust is what the continents are made of. So if you were to walk outside of school, you would be standing on continental crust. It's made mostly of granite. And there's other rocks too, but that's what it's mostly made of. And it's relatively thick. This could be up to 100. Right, we can see you've got continental crust here, right, is this lighter layer, right, and it's much thicker. When you get out under the ocean, right, you can see that the crust is much skinnier, right, it's very small. We'll talk about this lithosphere, asthenosphere stuff in a second. But the oceanic crust here, this little yellow layer, is much skinnier. So the crust under the ocean is much thinner. Alright, so continuing down, we've left the Earth's crust behind, and now we get to the Earth's mantle. Alright, this is the largest layer of the Earth's crust. Alright, it's the largest layer of the Earth, rather. It's directly below the crust. It's made of rock, and this rock is really hot, but it's still considered to be a solid. However, since it's so hot, it can actually move very slowly. So think of it as like cold peanut butter, right? It's a solid, but it can move very slowly. Right, it's about 3,000 kilometers thick. It's the biggest layer, right? And the biggest difference between the mantle and the crust is its different types of rock, right? And this has a lot more iron than the crust. Temperature, we're starting to get really hot right now, right? You don't need to know the numbers about volume and mass, but it is the biggest layer. And we divide the mantle into 3 layers that we're going to talk about quickly. Lithosphere, asthenosphere, which you do need to know how to say and spell, and mesosphere. So if we were to look in our diagram again, the mantle is going to be the red layer, right? Taking up most of the inside of the Earth. So special layers of the mantle. The lithosphere, litho means rock in Greek, comes from the uppermost part of the mantle and the crust. So the crust and the uppermost part of the mantle are created of, we call that the lithosphere. It's very solid, and it's actually broken up into large plates, and we'll talk more about those in the coming weeks. Under the lithosphere is the asthenosphere, right? Just under the lithosphere, and this is a kind of slow-moving, like silly putty-like layer. So it's still considered to be solid rock, but this is more of almost a peanut buttery texture, right? So it's not a liquid. It's not just going to slosh everywhere. It's not magma underground, but it's kind of a gooey, plasticky rock that can move slowly. And below that, we have the mesosphere, which goes the rest of the way through the mantle. So this is kind of just the rest of the mantle. We call it the mesosphere. It's very hot, but it's very stiff because of the pressure. So it can move a little, but not a lot. And this kind of gives you a diagram. You can see the lithosphere here includes this uppermost part of the mantle and the crust. So we consider that to be the lithosphere because they're so solid that they actually move together, even though you've got different rock types between the crust and the mantle. You got the asthenosphere under here, which is kind of gooey, and then the rest of the mantle continuing downwards. Lastly, we're at the Earth's core. All right, so we're at the very center of the Earth. The Earth's core has two main parts, the outer and the inner core. We'll talk about each one quickly. Both are made of metal, so we're no longer talking about rock. We're talking about straight up metal, and it's mostly iron and a metal called nickel. The outer core, the biggest difference between the two layers, the outer core is a liquid. All right, there's actually molten metal. So it is very, very heavy, obviously, because it's still metal, but it is a liquid, so it can slosh and move around. All right, and the movement in the outer core is the source of something called the magnetic field, which we'll talk about more in about a minute. All right, it surrounds the inner core. It's about 2,200 kilometers thick, but again, the key to the outer core is that it is a liquid. All right, that is very important to know. All right, so you got the outer core here. It's about 1,400 miles thick. It's pretty thick, so it's a liquid iron and nickel. And then as we get farther down, we get to the inner core. It's made of the same thing, solid iron and nickel, but it's a solid, even though it's hotter than the outer core. And the reason it's a solid is because of the incredible pressure of all the stuff above it. Right? At this point, you've got over 1,000,000 pounds per square inch. So think of an area the size of maybe a stamp that you would put on a letter and put 1,000,000 pounds of pressure on that. And that's the kind of pressure we're talking about here. All right. Lastly, the Earth's magnetic field. Right? You don't even know this term magnetosphere. I'm going to change it right now. Magnetic field. All right. So it turns out that the inner and outer cores of the Earth don't turn at the same speed as the rest of the Earth, which is kind of weird to think about. Magnetic field. All right, and this moving metal produces a magnetic field. So just like a magnet, like a regular magnet that you have, has an invisible magnetic field around it that will pull or push away other magnets, the inner and outer cores of the Earth create what effectively is a giant magnet inside the Earth. And it turns out that this magnetic field not only helps your compass work, but also protects us from some of the sun's harmful radiation, which is always good. All right, I know that was a lot. But these are the basic layers of the inside of the Earth. All right, so make sure you have 3 questions at the bottom, and I will see you guys in class next week. Enjoy the long weekend.